We are going to do problem 1 from the practice exam 3. And so here's the question. It says, consider this function. Okay, so the function is f of x equals x times the square root of 1 minus x. And the first thing we want to do is find all the critical numbers. Okay, so a helpful thing to know would be what a critical number is. So a critical number, this is just an x value where f prime of x is either 0 or f prime of x doesn't exist. So that's the definition of a critical number. And I bet for this function, the derivative not existing is not going to be a problem. So we're probably just going to find all the places where the derivative is 0. Alright, so what's the derivative? Let's use the product rule. So f prime of x is going to be equal to the square root of 1 minus x. Okay, so this first little x just disappeared. That's what happens in the product rule. And now I say plus and leave that little x alone. And now I take the derivative of the second part. Okay, so the 1/2 comes off. And I have 1 minus x. Okay, so the index exponent up here, whatever, gets knocked down by 1. So now it's minus 1/2. And by the chain rule, the derivative of the stuff inside the parentheses pops out, and that is negative 1. Alright, so let's put all this together. So f prime of x is equal to the square root of 1 minus x plus, and let's rewrite all this stuff. Maybe actually plus is not the best thing because it's negative, so let's just say minus. Right, minus. And what can we do here? Let's put x on top and 2 times the square root of 1 minus x on the bottom. Okay, so that's just rewriting things a little more nicely. And to find the critical numbers, we have to set this thing equal to 0 and solve. Okay. So I guess we should clear by this irritating radical 1 minus x, right? So let's multiply everything in sight by 1 minus x. The radical 1 minus x. So okay, multiply through. By this. Okay. Alright, so what happens after I do that? I get 1 minus x for this part because this thing times itself is 1 minus x. And it's going to cancel this 1 minus x down here. And I get minus x over 2 is equal to 0. Okay, so that looks good. Alright, and so now what? This is 1 equals, now let's just move both of these things over to the other side, and that gives me 1 is equal to 3x over 2. Alright, and so what does that mean? That means x is equal to 2/3. Okay, so great. And that's the only critical number. Okay. Alright. So I realized that I have told you a lie, or I made a wrong guess here when I said that there were probably no critical points of this form. Okay, so what we just did was we found all critical points of this first form, and now let's consider that there might be critical points of this second form. So we should ask ourselves, is there any point or any value of x for which f prime of x is undefined? So just looking at this version of f prime of x, you can see that if you put in 1, you're going to get a 0 in the denominator here, and that is undefined, right? So if 1 is in the domain of the function, then 1 is also going to be a critical point. And yeah, so 1 is a perfectly good number to put in here, right? 1 is a perfectly good number to put into the original function. So we found another critical number. So the other critical number comes from making this blow up here by putting in 1. So the other critical number is x equals 1. Okay, all right. So now let's go on to look at the second part of the question. It says, give all x values at which the absolute maximum and minimum occur for f in the interval -1 to 1. Okay, so we know from a theorem that whenever we have a closed interval, a function, a continuous function, this function is continuous on that interval, it's going to achieve an absolute maximum and an absolute minimum there. And so remember, the thing that we used to find where the absolute max and the absolute min occur is something called the closed interval method. And you can look that up in the book, but basically all it says is that all we need to do is check the critical numbers and also the endpoints of the interval. So that's all we have to do now to finish part B, okay? So we'll just find the values of the function at the critical numbers. So check critical numbers, and we'll also check endpoints. Okay, so when I say check, what I really mean is evaluate the function at those points. So we're going to evaluate the function at 2/3 and evaluate the function at 1 and at the other endpoint -1, and then the biggest value that comes out will be the max, and the smallest value that comes out will be the min. Okay, so in other words, what we need here is we need f of 1, we need f of 2/3, and we need f of -1. Okay, so let's just start with f of 1 here. And I remember that it's 0, but let's go up here and let's make sure. Okay, so why do I say that f of 1 is 0? Because when you put in 1, you get 1 times the square root of 0, which is 0. Okay. Alright, so easy enough. Maybe I should copy the function down here. The function is x times the square root of 1 minus x. Okay, so what happens when we plug in 2/3? We get 2/3 times the square root of 1 minus 2/3. So in other words, it's 1 over the square root of 3. Okay, so this is, you can write it in a little nicer form as 2 over 3 times the square root of 3. Okay, and now what happens when we plug in -1? I get minus square root of 1 plus 1, which is 2. So it's negative square root of 2. Okay, alright, and so this is clearly the biggest number that comes out. So the biggest number that comes out is clearly this. Okay, so here is the max, and it occurs at x equals 2/3. And this other thing is clearly the min because it's negative, right? So here is the min, the absolute minimum, and it occurs at x equals -1. And we're done. The question is over. Let's go to the next question.